January 24th, 2017. It's always good to pay attention to what mainstream is doing, the words they use. This should tie into the power of language in astronomy. A few patterns I've noticed here, and then I'll go into something about biology and astrobiology, a new meeting they're going to be having, which should be pretty interesting. Don't know if they've been reading what I've been writing, but we'll see. If you go to exoplanet.eu and go to the top and go to meetings, you'll see all these meetings on there. The first one, it says the Transient Universe with JWST at Harvard, Massachusetts in USA. JWST is the James Webb Space Telescope. It's going to be the most powerful telescope in the world ever because it's a space telescope. It's going to be in the near infrared. It's gold-plated beryllium plates, which means it's going to pick up infrared really good. I'm fucking thrilled about that thing going up. Cross your fingers when the rocket goes up somewhere over in the Atlantic Ocean. But that, if you click on that, it says Transient Universe with JWST. And I'll go ahead and read the rationale they have here. How can the transient community best use the unique capabilities of the James Webb Space Telescope? It will be launched in 2018, which is next year. The first proposal deadline is coming up fast, March 3rd, 2017, for the Director's Discretionary Early Release Science Program. The two-day workshop will bring together JWST and transient science experts. We will learn about JWST's unique capabilities and discuss the following two questions. How can transient science benefit from JWST? How can we make use of Director's Discretionary Early Release Science Program? So basically, they want to get on the fast track of whatever it is they discover. Boom, get out there to the public, show them what they got. That they, the taxpayer-funded $8.8 billion telescope wasn't, to waste. Everybody's really excited about it, so they want to get it all out there. But the really big word here that really sticks out to me is the use of transient community, transient universe, transient community, and basically transient science, if you will, because I think that's the rationale they're going with here. They're realizing that a lot of what they knew or what they claim to know isn't, up to snuff. And if they discover new things with this telescope, which they will, eventually they'll find out planet formation is stellar evolution. They have to set their minds in the right direction. They have to prepare their minds for what's going to happen. It's going to be a change in worldview. It's going to be a transient universe. It's going to be changing for them. And they have to prepare themselves mentally. Another one of the talks is from April 24th to April 28th of this year. It's called AbPsych 2017 in Mesa, Arizona. It says here, meeting location and date in Mesa, Arizona, April 24, 28. And the purpose and scope of this talk, or this get-together, is a series of conferences organized by the Astrobiology community. It says here, the theme for AbPsych 2017 is, quote, diverse life and its detection on different worlds. Mars and icy worlds in our solar system are increasingly recognized as habitable, even though increasing numbers of exoplanets and their stars' habitable zones have been discovered. The focus is shifting from identification of habitable worlds to detection of life on them. And that's where they're going to be focusing. I went over that in a previous talk. Among other topics, the conference will address setting the stage for geochemistry, setting the stage for biochemistry, yada yada yada. But more importantly, it has here questions I can answer with stellar metamorphosis. I'll go ahead and explain them out to you, read them out to you. There are 6 questions, 7 in total. What interstellar and protoplanetary disk processes determine the chemistry of a planet? What prebiotic chemistry sets the stage for life? Well, there's no protoplanetary process. Protoplanetary disk, that's just the destruction of 2 objects. That's what causes a protoplanetary disk. Planets don't form in those. That's the rationale behind that is the 17th century. It's outdated. Interstellar, that's also outdated. All the chemistry that happens during stellar evolution and life formation happens inside the star when it cools and dies. So the prebiotic chemistry is apparent inside of young hot stars. When the material is ionized as plasma, and that plasma cools and becomes gaseous matter, and molecules start forming. That's where all the prebiotic chemistry is happening. It's also in stellar metamorphosis. It says the biostellar evolution principle. As a star evolves, life forms and evolves on it. It's very simple. Question 2. Is a one-pot approach to prebiotic polymer chemistry possible? What are the future applications of origins chemistry? It says here, prebiotic polymer chemistry possible. Well, one-pot approach, I'm assuming they mean does it all happen in one space, in one area? And yes, it does. It happens on the star. It's a one-pot approach, I guess. What are the future applications of origins chemistry? Origins chemistry, not sure. But I'm pretty sure if you take a plasma and fill it full of organic chemicals, and just like the Milieu experiment, you heat it up and you let the participants fall out into a little container and you cool it down, you'll have amino acids formed. Just repeatedly do that. Just do that over and over and over again and see what happens. Take those amino acids, put them in another pot, do the same thing over again. Take those chemicals, put them in another pot, do it over again. Of course, change the temperatures and pressures as you do that. And I guarantee you some weird shit's gonna go down. But I don't know how much money it takes to do that kind of experiment. And I'm pretty sure it's gonna make a lot of people upset if you form some cellular looking things, but we'll see what happens. 3. Do habitable conditions exist on Europa, Enceladus, or other icy worlds? If so, for how long and how continuously have they existed? They can study that. It doesn't have any real power inside of stellar metamorphosis. Sure, they can find something there, yada yada yada, make a big deal out of it for news purposes, but it's not really all that important. It's not big picture stuff. Are extreme environments on Earth valid analogs to sites on Mars or icy satellites? No. Earth is habitable. Mars is not. Venus is not. A lot of icy satellites are not. It's simple. Earth has oxygen in its atmosphere in large amounts, has good temperatures, has good pressures, it has excellent gravity. It's not the same. What are the metabolisms utilized by life in different evolutionary stages and in extreme conditions? Well, study younger stars in the Earth. Study Neptune and Uranus. Instead of sending one satellite up there, which we've only sent one satellite up there in the past, since forever we've been making satellites. Instead of doing that, send more of them out there. Check them out. Examine those, because that's where the beginnings of life are going to happen. Those are the next stages of evolution before they become more Earth-like and they lose the thick atmospheres. It says here, how can molecular studies and the sequencing revolution help us understand the evolution of the 3 domains of life, including such evolutionary innovations as multicellularity and photosynthesis? Well, I have a microbiological complexity principle here, and it's pretty straightforward. The microbiology of a star increases in complexity as it evolves. If you want to understand how microbiology increases in complexity, study stars in different stages through their evolution. It's pretty straightforward. As well, if you want to understand how photosynthesis works, I'll go ahead and read this out to you. It's kind of long. All stars cool and synthesize photosynthetic molecules in their high atmospheres during late stages of their evolution. These late-stage stars contain hydrogen, carbon, nitrogen, oxygen, magnesium in their high atmospheres, as they are very light elements. They form in late stellar evolution in stars similar to Jupiter, Saturn, Neptune, and Uranus. As Jupiter and Saturn evolve, they will become blue, similar to Neptune and Uranus, from increased production of methane and other compounds, and the latter will begin to have greener tints, as photosynthetic bacteria synthesize in large amounts due to X-ray radiation and repeated mutation of the molecules on vast scales. These molecules will then be cycled through their turbulent, reducing atmospheres, feeding a multitude of feedback loops required for the formation of life. The radicals needed to form chlorophyll, which is the base molecule for photosynthesis to take place, are formed inside of evolving stars. Not random asteroids, comets, or molecules do not have atmospheres to cycle through. Basically, you have a big gaseous atmosphere and allows for all the molecular motion to go on. To think that these people believe life forms on cold, dead, lifeless, atmosphereless, magnetic fieldless rocks in outer space, and then it brings that here, they're not really looking at reality. They're not thinking clearly. Look at Earth. Look at all the life on Earth, because this is exactly where it's formed. Life formed on Earth when it was younger, and then just kept on evolving, and along with the star. They're intimately connected. To think that rocks brought life here that don't have the ingredients or the characteristics to form life, I don't think so. Another one says here, what is the evolution of biogeochemical cycles and environment on Earth and other planets? Well, biogeochemical cycles go hand in hand with the evolution of Earth itself. So you're going to have to take a new world view and realize that Earth was very, very, very different in its past. It was very, very hot, very, very big, had a huge gravitational field, much larger than it is now, and that's where it all starts. But I don't think they're going to be looking at it in the light that it needs to be looked at, because they still, in the previous statement up there, have the protoplanetary disk paradigm, which isn't going to suit them very well in the 21st century. All right, y'all, take it easy.